Hi everyone, welcome to the last chapter of the course. This is Unit D, Chapter 2, where we're looking at dreams of a sustainable future. And in Lesson 1, we're looking at sustainability, and we are going to be exploring two types of energy, electricity generation, and that's geothermal and tidal. But first, the lesson starts off with sustainability. So we are going to be looking at the concept of sustainable development. We're going to look at the impacts of developing different energy sources, but specifically in this section, we are looking at geothermal and tidal. Again, we're looking at also the technologies behind them, the advantages and disadvantages of each of these energy sources when we study them. So in this lesson, it's geothermal and tidal, and we're going to look at how tides are caused by the moon, the sun, and the earth, and then how we take that energy and we convert it to electrical energy. Here are your textbook pages too for reference. So first off, why are we even looking for alternative energy sources? Well, by now you should probably know that these different fossil fuels that we are using currently have quite a few pollutants that come along with them, carbon dioxide being one, and methane. They contribute to global warming. And we also get some other emissions, nitrogen oxides and sulfur dioxides. And you saw that in chemistry that these both cause acid deposition. So at least for even though these two reasons, these are reasons why we want to find other resources. Also, we want to look for renewable resources. These ones are non-renewable, right? So eventually they're going to run out at some point. So we do need to look at what else is out there at the same time that we want to reduce our impact on the environment by finding sources of energy that don't make these kind of pollutants or as much of them. So ideally, we want to find a low-cost option for electricity and a type of electricity that is low carbon emitting. And even better, on top of that, we would like to see a sustainable resource, so something that is renewable, if possible. And then you can see there's a target cost here. So So if we can manage our costs are in blue, and you can see the cost for coal is a good target cost here. It's reasonable, but unfortunately the carbon dioxide emissions are really high. So we want to get that target cost. So we want to, if you look at something like solar, it's quite expensive. If we can get that target cost down and keep those carbon dioxide levels down, then we've got a really something to work with, right? And you can see why the move to natural gas, we've got that carbon dioxide levels down and your costs are down. Remember, you're having methane in here released with natural gas, but that's not accounted for in this graph. Anyway. So what does sustainable development mean? Well, it means that we're not going to run out of our resource in the near future, and it should last for generations to come. But with that, we want to have something that's ecologically sustainable, so it has minimal impact on the environment. It's societal sustainable. So that means we can maintain our standard of living that we're used to, having our phones, our housing, our cars, jobs, technologies, all these different things that we are used to. Also, we want to have something that is economically sustainable. So we're still able to provide jobs and generate revenue. The way we can generate energy, it's also efficient. So that is what sustainable development means. So because we're looking for sustainable development options, and how do we get there? Well, some of the ways that we can get there is through renewable resources. So these are some of the renewable resources. Today's lesson looks at tidal and geothermal and how they work. We've already done nuclear, and tomorrow's lesson will cover the other four. So the word geothermal, so we got geothermal first. When you see this word, you want to think geo, that means earth, and thermal means heat. So it's heat from the earth, right? It's a renewable source, originates in the core of the earth from radioactive decay that's occurring in the core, so right down in that center. and it produces a lot of heat, and that heat tries to get up to the plate, up to the surface, but it comes up usually through the boundaries as either volcanoes, hot springs, that kind of thing, all that steam from those hot springs, right? So it's trying, all that heat's trying to get a way up through those plate boundaries in the Earth's crust. An example of where geothermal energy is being used heavily is in Iceland. Also, I saw New Zealand's very close to this. New Zealand has about 15% of their energy coming from geothermal, whereas Iceland has about 25% of their energy, electricity, I should say, coming from geothermal. Not only do they use it for electricity, but they also use geothermal for heating in their building. It says the hot springs produce enough energy to heat 80% of the buildings in the capital city of Reykjavik. So the geothermal energy, it's currently being used for heating or electricity in over 30 different countries. As of 2020, when I could find information, Canada doesn't have any plants creating electricity yet from geothermal. However, it is used in lots of houses and buildings as a heating source. You may even know somebody who's heating their house with geothermal, because a lot of individual houses will actually have that process set up. If you want to read more about some of the current projects that are happening in Alberta and across Canada, there's a link here that gives you a bunch. There's a few that look like they're going to come on board anytime soon, producing energy pretty soon. So how does geothermal work? Well, basically the idea is very similar up until about this point. It's different, and then the rest you'll see this whole part of generating electricity very similar. So what you do in geothermal is you're going to pump cold or cooled water down to the area where you might have magma or hot spring or whatever it is, where you have hot location underground. That water heats up, it turns into steam, right? Okay, now we got steam. Perfect. We can send that steam through a turbine that turns the generator. We create electricity. They just have a little transformer here to step up that electricity into our electrical grid. So again, same idea as all the other energy. We have a turbine that turns connected to a generator that creates our electricity. Just how do we get that turbine to turn? We heat the water by using the energy from the earth and nuclear reactions that are happening in the earth. All right, so just to look at the actual energy transformations, they're very similar to the nuclear energy plants. However, we're not controlling that nuclear reaction that's happening. That's in our core of our Earth. And we've got all that potential energy, intranuclear potential energy in the core of the Earth, that we are taking the heat or the thermal energy from that. Okay. That thermal energy is transferred into steam, and it turns the turbine, which is then kinetic. When you have something moving, it's kinetic. So you have the turbine turning, you got the generator turning, and then the generator turns it to electricity. All right, watch this video, excellent video showing the different uses for geothermal too, on how you heat a house with it versus creating electricity. It is a must. Also, benefits and disadvantages of each of these types of energy sources, we want to make sure we have a good, strong understanding. So in terms of societal benefits, geothermal is abundant, so you don't need to actually live by one of those fault lines. You can use geothermal, it's just a little bit different. The disadvantage is if you're near like one of those you're near a hot spring or something, you've probably smelled that rotten egg smell. So you do get that hydrogen sulfide produced with a geothermal energy. It's basically released from the earth. Also, carbon dioxide can be released as well. So it's a lot less than with a fossil fuel, but just keep in mind that it's not emission free. Okay, so there are some emissions of hydrogen sulfide and carbon dioxide. Also, there is thermal pollution of the air. You need to actually cool that water down again before you can pump it down into the earth and create the steam. Benefits, it is renewable. And I'm going to get rid of this about no gaseous emissions. We're not creating extra emissions, but they are released in the process. So also, there's no fuel costs. We're not having to pay to bring in a fuel, but this number of sites are definitely used to be restricted to the boundaries of the crust, but there's a little bit more opportunities for a wider use, but definitely more limited in where it can be used. All right, here's an example diploma question. So we have some different energy conversion pathways. I want you to read through this, pause, and see what you're going to get for your answer and why. So when we take a look at this, the production of electricity from geothermal energy is most similar to this pathway. Well, we know that geothermal energy starts with energy in the center of the core of the Earth, which is a nuclear reaction or nuclear potential energy that is in the elements in there, isotopes. So we're looking at stored potential energy as the beginning, and that energy is transferred to the water as heat or thermal energy, and that steam that is created moving fast turns the turbine, turning the generator. The generator creates us the electrical energy. So that is where D is the answer. So keep in mind, geothermal energy does not originate with the sun. So it's not one of our energy sources that comes from the sun. Does not have anything to do with the sun. No sun for geothermal. All right, the second type of energy source that we're going to look at is tidal energy. Now, we don't have this in Alberta, obviously. We do not have high enough tides to make this feasible. But a place like here in Guernsey, you can see the dramatic tide rise here. So all these boats are on the bottom of the ocean here. You can see the post holding up the dock here, and that same post is right here, and you can see how high that tide has come in. So you can see that's how high your tide is here. Very high. This is a great place for this kind of electricity to be formed. Okay, so how do tides even happen? This is a good, you do need to understand how tides are created. There is a video here, so make sure you take a look at the video. But basically, tides are created 4 times a day. So you have 2 high tides, 2 low tides, and they're due to the moon moving around the Earth. Okay, and depending on where that moon is, if it's lined up with the sun, you get even more of a gravitational pull on the Earth. So if you have moon and sun lined up, you are having a big pull on the Earth. But what can move on the Earth easily? Well, the land doesn't, but the water does. So the water will swell in the areas of the Earth that are in line with the moon and the sun. Okay, that creates a high tide. So you can also have a high tide created when your moon is on the other side of the Earth from the sun, but they are lined up with the Earth. Okay, so they're both pulling outwards, and that'll also create a high tide. When you get a low tide is when the moon is perpendicular to the sun, so they're not in line. Okay, so this will give you a low tide. Now watch, these descriptions are a little bit off, so you got your tides opposite each other. Okay, so you're getting these tides 4 times a day, two highs, 2 lows in one day. So the water's moving back and forth quite a bit. So let's take this energy of this water moving, right? That's a lot of kinetic energy. So it doesn't matter which way that energy is flowing, we're going to grab that energy and get it to turn a turbine. So some advantages of this type of energy source is that they definitely do not have any emissions. Okay, there's no fuel source, and they have a little effect on the marine ecosystem. There is a little bit, but not a lot. Unfortunately, they only can work in very limited places, and they have small amounts of energy. In Canada, we have one power station like this in the Bay of Fundy. If you've ever been there, there's a picture of the Bay of Fundy. You can walk around underneath here, and then later, you can see the water level goes right up there. If you ever have a chance to go check it out, I can't remember what it is, 15 meters. Yeah, 15 meters, I think, is the highest difference from the low tide to high tide. It's quite dramatic. So how tidal energy works, you have these generators, turbines down the bottom of the ocean, sitting on the floor, and as the water moves in, the tide pulls out or pulls in. So if we look at the energy transformations for tidal energy to produce electricity, and then we have to look at the gravitational potential energy pulling on the water, right, from the moon or the sun's gravity, pulling on that water to create the tide. And that causes the water to move. So we've got kinetic energy, which then turns the turbine. And then when that turbine turns, there's a generator in there creating the electrical current that we can use. The only tidal energy plant in North America is in the Bay of Fundy. We talked about this one already. Oh, there's the tidal range. They're huge. The largest in the world, about 17 meters in tide, difference between low tide and high tide. Pretty amazing. Video on tidal energy. Make sure you watch this. Very informative video. Also, benefits and disadvantages of tidal energy. Are there any environmental? No gases are produced, no thermal pollution either, and it is renewable. It's just going to keep going as long as we have a tide. There are some disadvantages in that it may affect aquatic animals living in that environment. There's no fuel costs, so no cost there. Relatively inexpensive compared to some other energy plants. It's not efficient enough to meet all of our demands, and we don't have enough resource areas where we can use it. Can it be used worldwide? No, can't be used in Alberta. We don't have that kind of tide. That's the end of this lesson 2.1, and you'll learn about some more energy and electrical energy sources in the next lesson.